This problem is now written out a different way, but we see that we are dividing by a binomial, and that is the clue to us that we want to write this out as a long division problem. 4t to the third plus 4t to the second minus 9t plus 3. Okay, let me move that up a little bit. We only look at the 2t. 2t times what makes 4 to the third? Answer, 2t squared. The 2t squared on top gets multiplied by both things on the side there, giving us 4t to the third plus 6t squared, which we are then going to subtract by adding the opposite. 4 minus 6 makes negative 2t squared. Bring down the minus 9t. We then ask, 2t out front multiplied by what makes negative 2t squared? And the answer is negative 1t, or just negative t. That negative t gets multiplied by each term on the side, giving us negative 2t squared minus 3t. Adding the opposite changes both of these to plus signs, and now we can see that adding we get negative 6t plus the 3 we bring down. We ask again, 2t out front times what makes this negative 6t? And the answer is minus 3. So negative 3 gets multiplied by each term inside over there at the left, making negative 6t minus 9. And adding the opposite, we have 12 as the remainder, and so we would say plus 12 over our divisor of 2t plus 3. Using my shortcut little partial check, I would take this positive 3 times the negative 3, which is negative 9, add on the remainder of 12, and verify I get to positive 3, which I do, and so odds are I have not made a subtraction error along the way. Now we come to our first twist in polynomial division. Notice that what we are dividing into is skipping over an x term and an x squared term and an x term. When we go through and write out our long division, we insert 0 terms. So we're going to have 0x squared for the missing x squared term, a 0x term for the missing x term, and then bring down the minus 27. You'll see in a second why that is necessary. Let's begin the division. X times what makes x to the third? Answer, x squared. X squared up above gets multiplied by both terms on the left, and we get x to the third minus 3x squared. Notice if we had not put these placeholders in, that would be lined up under the minus 27, and that could have led to a little bit of confusion. Now we've got like terms aligned, we're going to add the opposites and have 3x squared on the next line. If you want to bring down this plus 0x, you can. We now ask, x times what makes 3x squared? Well, the answer will be positive 3x. We multiply that 3x at the top by both terms on the side, and that gives us 3x squared minus 9x. Again, add the opposite. We have a minus and then a plus sign. And adding down, we have 9x. I'll now bring down this minus 27 and continue the process. X multiplied by what makes 9x? Answer, positive 9. 9 times each term on the side gives us 9x minus 27. And adding the opposites, we see that there is no remainder. And so we basically, when we have no remainder, have been able to factor this x cubed minus 27 into x squared plus 3x plus 9. Notice, I can write x cubed minus 27 as x minus 3 times the next parentheses, x squared plus 3x plus 9. And if you were to do all the distribution and check that again, the middle terms would all cancel each other out. You'd have your first term, x times x squared, making the x cubed, and the last term, minus 3 times positive 9, making that minus 27. And later on, when we get into factoring, we will learn the shortcut method for factoring the difference of two cubes. In this next problem, we are dividing by a p squared plus 2. Now we do not need to put a placeholder over here on the left in our divisor. It's only placeholders underneath the symbol here if there are any missing terms. And I see 4, 3, 2, 1, none. And so there are no missing 0 terms I need to put in. So I'm just going to write this as I see it here and then begin the division process. When I do so, I ask p squared out front times what makes p to the fourth? And the answer is p squared. P squared at the top gets multiplied by each of these at the side, and that gives me p to the fourth plus 2p squared. Notice that I skipped over a position, and I really want to be careful that I align my like terms. So I'm going to add the opposites. This minus p to the third is going to slip right through. I'm going to have minus 6p squared there, and I'm going to bring down the minus 2p. And that's really the only trick in this process. Again, p squared at the left times what makes negative p to the third? And the answer is minus p. That gets multiplied by each at the left to give us minus p to the third minus 2p. Adding down the opposites, those are going to cancel out. We'll have the minus 6p squared coming down and the minus 15 left. P squared times what makes negative 6p squared? Answer, minus 6. Multiply that minus 6 times each term on the side to give us negative 6p squared minus 12. And again, add the opposites, and we will have a remainder of negative 3. Now when you go to write this remainder, you can either go minus 3 over p squared plus 2, or you can go plus a negative 3 over p squared plus 2. Now personally, I prefer to have a plus here and then a negative on the top of the fraction for reasons that come out later. Sometimes you're subtracting an answer that's got a binomial in the numerator and you have a distribution of a negative issue. So I like to go plus my remainder at all times.